continuation, this is now still part of vertical alignment. That is your unsymmetrical parabolic curve. Kung merong symmetrical, of course, meron ding unsymmetrical. No? So for the unsymmetrical parabolic curve, a vertical highway curve is at times designed to include a particular elevation at a certain station where the grades of the forward and backward tangents have already been established. It is therefore necessary to use a curve with unequal tangents. So kung meron na yung forward and backward tangent daw, as much as possible, dapat magkaiba yung left-hand side of the curve with the right-hand side of the curve. So basically, we are having a compound curve, but in a parabolic manner. Okay? Establish if it is therefore necessary to use a curve with an unequal tangent, or basically a compound curve, which is usually called as your unsymmetrical parabolic curve, or asymmetrical parabolic curve, where one parabola extends from PC to the point directly below the vertex, and a second parabola which extends from this point to PI. Now, kung dalawa yung ating curve, or we are dealing with a compound curve, so basically, dalawa rin yung ating elements with respect to the left-hand side and with respect to the right-hand side. So, meron tayong dalawang length or dalawang horizontal length of the curve, which are unequal. And the location of H is no longer on the center of the parabolic curve. Okay? L1 is the length of the parabola curve on the left side of the vertex. And L2 is the length of the parabolic curve on the right side of the vertex. Subscript 1 yan na. Hindi ko na-type ng 1 saka 2. Subscript 1 and subscript 2. Then G1 and G2 are G1 is the slope of the backward tangent, G2 is the slope of the forward tangent. Now, the formulas involved in the unsymmetrical parabolic curve. So, parehas lang yung figure, di ko na pinalitan. More or less, parehas lang po yung element yan. Palitan nyo lang yung L divided by 2 as L1 at saka L2. Yun lang naman yan. Then, if you wish, you can change A as V1 and B as V2. Okay? Now, for the formula, the horizontal distance or the offset distance from PI on the surface of the curve is basically the absolute value. Absolute po yan, bar. Si G1 minus G2. Absolute value ni G1 minus G2 considering the sign of the grade times that is supposed to be L squared. Yeah, H supposed to be L squared. So absolute value, mamaya na nasa ano naman yun, nandun sa example. The absolute value G1 minus G2, L2 all over 2 times L1 plus L2. Computing for H1 is basically H over 4. H2 is also H over 4. Then L1 is again 2H L2. It is 2H L squared all over L2 G1 minus G2 minus 2H. And the squared property of a parabola. Ito naman at any point along the left and the right side of the curve. Subscript 1 yan at saka subscript 2. Okay? Then y1 over x1 squared equal to the computed h over L1 squared. To compute either S1 and S2, parehas lang naman. And at along any point of the curve. Then same goes for the right side of the curve. And location of the highest or lowest point of the curve. Now, check ninyo. Dito sa location ng S1 at saka S2, or location ng highest at lowest point of the curve. Now, whenever you're going to check this from PC, when L1 G1 over 2 is less than H, compute for S1 equal now to G1 L1 squared over 2H. When from PT, when L1 G1 over 2 is greater than H, you can then compute S2 as G2 L2 squared all over 2H. Ganun lang naman po yan. Okay? Naintindihan po? Then you can compute H as equal now to L1 over 2 of G1 minus G2. G2 yan. Bakit naka G3? Then H is L2 over 2 of G1 minus G2. Now, for the example problem for unsymmetrical parabolic curve, nandun sa continuation na video nito, yung solution. Okay? Unsymmetrical parabolic curve, isa lang yung ibinigay kong example. Ito lang naman po yan. More or less, same solution lang yan with the symmetrical. Nag-iba lang ng horizontal distance with the left and right side of the curve. Okay? For the unsymmetrical parabolic curve, a unsymmetrical parabolic curve has a forward tangent. Kung forward tangent, ibig sabihin, pataas yung ating curve. Forward tangent of negative 7%. So, pataas yung ating curve. Meron tayong summit. Then, the back tangent of positive 5%. The length of the curve on the left side is 80 meters, while on the right side is 100 meters. The intersection of the tangent lines are located at station 11 to 80 with an elevation of 108 and 32 meters. Find the elevation and the station of the highest point of the curve. So I'll be showing on this example two ways in which you can solve the elevation of the highest point, either by the vertical analysis or by the curve analysis. Okay? Pakihintay na lang po yung pre-recorded lecture for this example. Idudugtong ko na lang.
So in continuation with unsymmetrical parabolic curves, this is the example that I have given from the recorded lecture. An unsymmetrical parabolic curve or a vertical curve has a forward tangent of negative 7%. So forward tangent, that is negative 7%, and a back tangent of positive 5%. So that is your G1, 5%. The length of the curve on the left side was identified as 80 meters, while on the right side as 100 meters. So on the left side is 80 meters and on the right side is 100 meters. The intersection of the tangent lines PI has a station of 11 to 80. Okay, 11 to 80 with an elevation of 108, 108.32 meters. Okay, find the elevation and the station of the highest point in the curve. So for us to do that, we need first to identify the highest point of the curve. Highest elevation on the curve. So gawin muna natin yung ating curve. So more or less, that is your vertical curve. Now, we need to presumably identify the location of our point S or the highest elevation. Let's just say, nandito yung ating highest elevation. Okay? This is your PC and this is your PT. that the highest elevation are then located by computing the S1 and S2. Then compute for the difference in the location with D for the later on solving the station of the highest elevation. Then the horizontal distance from the curve with the point of intersection. We also have the positive grade of 5% back tangent and a forward tangent of 7% downward. We need first to identify our H. Okay, for us to solve the summit as S1, that is basically G1 L1 squared over 2H. That for us to do that, we need first to solve for H. H is basically equal to L1 L2 times A, or the difference in subgrade, all over 2L1 plus 2L2. L1 left side is 80 meters, right side 100 meters, and A is the absolute value of G1 plus G2, 0.05 plus 0.07. Absolute value ha, baka nakakalimutan nyo. Absolute value over 2 times 80 plus 2 times 100 give us H of 2.667 meters. Then we can immediately solve for the location of the summit, but we need first to compare that with S1 and S2. S1 grade is 0.05 for G1, length of 80 meters squared over 2 times 2.667 gives us S1 of 59.993. But we need to check if it is within the span of S2. Kung yung S2 ay lalagpas sa S1 or kukulangin siya. Okay? Okay. Such that S2 should not be more than 100 meters para ma-determine natin kung sino mas mahaba at mas maikli. The summation of S1 and S2 should not be more than 180 meters. So check S2, which is G2 L2 squared over 2H. That is 0.07. Disregard the sign, that is only for the direction of the subgrade, squared all over 2 times 2.667 gives us S2 of 100 131.2335 meters. So S2 is more than S2 plus S1 is more than 180 meters. But with that note, let's adopt S1 and recompute for S2. Recomputing S2 is simply 180 meters minus S1. 180 minus 59.993 gives us S2 of 120.007 meters. Okay? Kung nakuha na natin yan, basically, S1 is the location of the summit. The highest elevation within the vertical alignment is 59.993 meters from PC. So 59.993 meters. And S2 is 120.007 meters. The difference in their elevation, the difference on their distance, D, is 80 minus 59.993 equal to 20 20.007 meters. Okay? Now, how are we going to solve for the station of the highest point and its elevation? Okay? There is two way that we can solve this one. First one is for us to identify the vertical distances of this distances. Vertical distance of PI with the tangent line VS and the vertical distance of the tangent line with the curve, which is YS. Or we can solve for the vertical distance of PI with PC and the vertical distance of the point on the highest altitude on PC, which is HA. Dalawa lang naman yan. So, dun na lang tayo dun sa hindi pa natin nagagamit na formula. Compute natin si VS. Computing VS is simply equal to the difference. Ito kasi yan. Difference at saka yung elevation. Ayan yung triangle natin. Slope lang. VS is D times G1. That is 20.007 times 0.05. Gives us VS of 1 meter. And YS. Ito yung isang formula natin when it comes to vertical curves. It is x squared over ys equal to L1 squared over H. Okay? Ito yung basically, ito yung x. Yan. Ito yung x. Ito yung y. So, yan lang naman yun. So, x is 59.993 squared over ys, which is our unknown, equal to 80 meters L1 squared over 2.667. Simplify gives us ys, or the vertical distance of the tangent line. Of the tangent line towards the highest or the peak of the vertical curve is 1.5 meters. So, meron na tayong VS at saka YS. We can simply solve the elevation, the station of S. Minus lang naman yan. At saka yung elevation, kayang-kaya na natin yan. Okay. Now, solving for the station of the highest point, S, is simply equal to the station of PI times the difference distance D. Station PI was identified as given as 11,280. The D is 20.007. Station on the highest elevation, or the highest point on the curve, is basically 11 of 259. 259.993. So, yan na yung ating answer with the station. But, how about the elevation? Elevation of S is basically, sa ating figure, mapapansin ninyo, that is PI, elevation ni PI, minus ni VS, minus ni YS. So, elevation PI minus VS minus YS. Elevation PI is 108.32. VS is 1 meter. YS is 1.5. So, elevation of S is simply equal to 105.82 meters. So, sabi ko kanina, dalawa yung solution natin dito. This is the first one. The second one is involving the total vertical distance of PI with PC, then the vertical distance of PC with the curve on the highest point. How are we going to do that? Let's first compute HA with regards to the highest point. This S1 located yung ating highest point based on the S1 distance over 2 times G1. Okay? Kasi nandun siya sa G1 grade. Dito yan. Okay? So, S1 is 59.993 over 2. G1 is 0.05. We can then compute HA as equal now to 1.5 meters. And the vertical distance of PI to PC is basically the slope. G1 times L1. Ito lang yun, triangle. Ito yung triangle niya dyan. Slope lang po. That is your slope. Compute natin si V. So, that is 0.05 times 80 meters. 0.05 is then times 80 is now equal to 40 meters. 40. Should be 4 meters. So how are we going to determine the elevation S? Elevation S is basically the elevation of the point intersection on the point of intersection minus the vertical distance plus HA minus the vertical distance plus HA. Elevation of PI is 108.32. Vertical distance is 4 meters plus HA of 1.5. So the elevation of S should be also equal to 105.82 meters. So, yan na yung ating final answer. For this problem. So, how about if you're asked to identify the elevation of, let's just say, point A, which is at this specific distance from PT, let's just say that is XA. So there are two ways in which you can solve this one again. Solve VA and YA, or solve again V and solve for H, and so forth and so forth at any given point on the vertical curve lang naman yan. So that is your example problem for the unsymmetrical parabolic curve and many more. Pare-parehas lang naman po yan ang solution, but nag-iiba lang sila with the symmetrical parabolic curve. Again, for symmetrical parabolic curve, the left and right side of the vertical curve has an equal distances for both forward and backward tangent. But with the unsymmetrical, of course, magkaiba yung distance length ng left and right side of the vertical curve. So that is it for your unsymmetrical parabolic curve example problem.